For as long as we've looked to the skies, the universe has remained a vast, endless mystery, full of secrets beyond anything we could have imagined. Many of these cosmic enigmas have made it difficult to freely share information that's crucial for scientific progress. But now, something truly baffling has emerged, something that challenges what we thought we knew. The latest data from our most advanced telescopes has uncovered a phenomenon that doesn't align with any current scientific logic. This cosmic mystery has left scientists across the globe in a state of deep confusion. A recent breakthrough from the James Webb Space Telescope has cast doubt on one of the foundational ideas in modern cosmology, the Big Bang Theory. Joel Rowand has taken a closer look into this discovery, which has shaken the scientific community. The telescope has revealed something both astonishing and disturbing: the apparent disappearance of 900 trillion stars. After more than 2 years in operation, the $10 billion James Webb Space Telescope is already proving to be an invaluable investment. Far more powerful than its predecessor, the Hubble telescope, it has given us never-before-seen views of deep space. In July 2022, the James Webb Space Telescope began studying extremely long wavelengths coming from galaxies located billions of light-years away. These wavelengths are forms of radiation outside the visible spectrum, known as redshifted ultraviolet light. The telescope has revealed cosmic structures and regions of space that had been hidden from us, areas that even the Hubble couldn't observe. But its most disturbing discovery remains the unexplained disappearance of 900 trillion stars somewhere in the vacuum of space. There's no sign of where they went, and the data only deepens the mystery with each new reading. This shocking observation, stars vanishing without a trace, raises urgent questions. Where did these stars go? 2 leading theories attempt to explain the phenomenon. One possibility is that the stars may still exist, but have dimmed dramatically or are concealed behind interstellar dust. Alternatively, they may have collapsed into black holes directly, bypassing the explosive supernova stage entirely. The second theory is far more unsettling. It suggests the universe itself may be undergoing a kind of gradual disappearance, a cosmic process we are powerless to prevent. Nearly a century ago, scientists proposed the idea that the universe is expanding. The light from distant galaxies appeared to show that they were moving away from us at increasing speeds. This didn't mean galaxies were racing through space, but rather that space itself was stretching, pulling galaxies apart. This concept has been the cornerstone of cosmology since the 1920s. Then, just about 2 decades ago, researchers discovered that this expansion wasn't just ongoing, it was accelerating. Today, we know that the farther a galaxy is from us, the faster it seems to be receding. Even if we could travel at the speed of light, some galaxies would still remain out of reach. When we observe light from a star that's traveled for 100 years to get to us, we're seeing that star as it was 100 light-years away. But when we see light from a galaxy that's taken 100 million years to reach us, that galaxy is now much farther away than 100 million light-years. Because the universe has continued expanding in the time it took the light to arrive. This expansion also causes the light from these galaxies to shift toward the red end of the spectrum. As light travels through the growing fabric of space, its wavelength stretches. If the universe were static, the light's wavelength wouldn't change. But because space is expanding, the wavelength grows longer, producing what scientists call a redshift. This redshift confirms that the universe is expanding, but it also allows us to study how the universe has evolved over time. By analyzing light from distant cosmic sources, scientists can track how far away those sources are, how long the light has traveled, and how the universe has changed during that time. The redshift not only reveals distances, it helps map out the entire history of the universe's expansion. It also lets us learn what the universe is made of. Right now, we estimate that about 68% of the universe consists of dark energy, the mysterious force behind accelerated expansion. Around 27% is dark matter, and just 4.9% is the ordinary matter that makes up everything we see: protons, neutrons, and electrons. An even smaller fraction is made up of neutrinos, antineutrinos, and photons. Thanks to this detailed understanding of the universe's components, we can apply Einstein's theory of general relativity to predict what lies ahead. What we've learned is staggering. The universe is ruled by dark energy. Because of this, galaxies not bound by our own gravitational pull will eventually drift away at speeds that increase forever. Over time, the space between us and these galaxies will stretch so dramatically that even light traveling at the fastest possible speed will never bridge the gap. At a certain point, the distance will be so great and the expansion so rapid that photons emitted by these faraway galaxies will simply never reach us. Though some galaxies may be only 18 billion light-years away, the space between is growing too fast for light to cross. Our observable universe may span about 46 billion light-years in all directions, but even with that, we can only access about 6% of all galaxies that exist today. The implications are both humbling and alarming. Every second, between 20,000 and 60,000 stars cross the threshold from being observable to unreachable. The light they emitted a second ago will still arrive eventually, but anything they shine from this moment on will never reach us. This relentless reality underscores how fleeting and precious every moment of cosmic connection truly is. From a more hopeful point of view, this also serves as a reminder that if we want to explore beyond our small corner of the universe, beyond our local group of galaxies that includes the Milky Way, Andromeda, and around 60 smaller satellite galaxies, we must act swiftly. Of the estimated 2 trillion galaxies that currently exist, only 6% remain accessible to us from the Milky Way, and that number continues to drop. This means that 94% of the galaxies in our observable universe are already slipping beyond our reach because of the ever-accelerating expansion driven by dark energy. If we don't develop the technology to travel beyond our local group, humanity may find itself permanently isolated, unable to explore, contact, or even detect the rest of the cosmos. The expansion of the universe isn't slowing down. Our gravity isn't strong enough to stop it, and so the universe continues to grow, silently and unstoppably, pushing most of its wonders out of our grasp forever.